Right, the lesson today, we are going to look at the general form and the root form of a quadratic equation. By the end of the lesson, you should be able to understand the difference between the general form and the root form of a quadratic equation. You should know how to convert the general form to the root form by factorization, obtain the roots or the x-intercepts of a quadratic equation by null factor law or by using the quadratic formula. Now, with the quadratic formula, you should also know how to use the discriminant of the quadratic formula to determine the number of roots. Then you need to be able to identify the critical features and sketch a parabola using the root form. And finally, you should be able to derive the formula of a quadratic equation using the root form. Now, let's start off with the general form of a quadratic equation. This is the general form of quadratic equation. Y equals to ax squared plus bx plus c. Now, you must make sure that for a quadratic equation, a does not equal to 0. If a equals to 0, y equals to bx plus c, that is actually linear. So, remember, for a quadratic equation, y equals to ax squared plus bx plus c. Now, what if a is 1, b is equals to c equals to 0? We will then get y equals to x squared. Remember, this is actually the basic parabola. What about if a is 1, b is not 0, c is not 0? Y is therefore x squared plus bx plus c, and this becomes a monic quadratic equation. Right. Let's have a look at the number of x-intercepts. You should remember that for a quadratic equation, when it's plotted on a Cartesian plane, it is the shape of a parabola. And all parabolas have a y-intercept. Now, it may have two x-intercepts, one x-intercept, or no x-intercept at all. The other word for x-intercept is actually the root. Alright, remember the word root. Now, what I want you to do next is to solve the following quadratic equations. Alright? Use your pen and pencil to solve it before you actually check my answer. Pause the video for a while and try it out. Now, for the first one to solve that is actually factorizing. X minus 4, x plus 2 equals to 0. Therefore, x equals to 4 or minus 2. What about the next one? The next one is actually a perfect square. It's actually x minus 5 all square equals to 0. Therefore, x equals to 5. Next one is difference of perfect square or difference of two squares. It is x minus 4, x plus 4. Therefore, x equals to 4 or minus 4. And finally, for number 4, x squared is minus 4. There is no way we can solve it. Now, I want you to consider this equation and think about it as y equals to x squared minus 2x minus 8 for the first one. Since we know that x squared minus 2x minus 8 is actually x minus 4 and x plus 2 factorized format, we can rewrite this as x minus 4, x plus 2. Alright? So here I have shown you this is the general form and this is the root form. The next one is the same. Y is actually x minus 5 all square, which is the root form. Next one, y is equal to x minus 4, x plus 4. That is the root form. For the fourth one, we can't actually write in the root form at all. Alright? So now, what I want you to do is I want you to actually get your class pad out. We are going to start plotting all four graphs And let's look at the critical features of the graph, especially in terms of the root form. Alright? First one is y equals to x squared minus 2x minus 8, which is equals to x plus 2x minus 4. Alright, I have used my class pad to plot it. You should pause your video for a while and plot it and see whether you get the same graph as I do. Let's have a look at the graph once you've plotted. I'm going to start off with the x-intercept or the root. So the x-intercept or root is actually this 2 point here, minus 2, 0, and 4, 0. Alright, let's go back one slide. This is where you have got the solve when you solve the equation. Alright, x squared minus 2x minus 8 equals to 0, x equals to 4 or minus 2. You can see that here, x equals to minus 2 or x equals to plus 4. That's the x-intercept. Then, what about the y-intercept? Y-intercept, you can read it from the general form, which is minus 8. So it's 0 minus 8. Or if you have the root form, you just multiply the two constant. Then we look at the axis of symmetry. Axis of symmetry is x equals to 1. Alright, I'll show you how to derive that in a few minutes. And then we look at the turning point is 1 minus 6. 1 minus 9. Let's start off with the axis of symmetry. You can see that this point here is actually midpoint between minus 2 and 4. So therefore, if you are working out the equation of the axis of symmetry is x equals to 2 minus 2 plus 4 divided by 2, which is minus 2 divided by 2, which is 1. So that is actually the midpoint, since this is axis of symmetry. So the distance between this point and the axis of symmetry must be the same as the distance between that 2 points. Alright? And since we know x equals to 1, and we know that turning point actually occurs at axis of symmetry, so substituting 1 into the equation, so y equals to 1 plus 2 times 1 minus 4, which is 3 times minus 3, that will give me minus 9. So we can solve it. Here, by using the root form, I have identified the root or the x-intercept. The y-intercept, either read it from the general form if you have the general form. If not, is the root form is actually the multiplication of the constant. Alright, bear in mind, this is a monic quadratic equation. Axis of symmetry is the midpoint between the two solution, the two roots, and therefore is minus 2 plus 4 divided by 2. Alright, and finally substituting x equals to 1 in this case into the equation, you'll get the turning point. Right, let's have a look at the next one. I'm going to do y equals x squared minus 16, x plus 4, x minus 4. This case, straight away, you know that the roots or the x-intercepts are actually these 2 points, minus 4, 0 or 4, 0. Alright? Y-intercept, you can see that is actually minus 16 from the general form. Or just multiply plus 4 and minus 4. Remember, monic only. And then if you look at axis of symmetry, this time x squared minus 16 is actually the basic parabola translate down by 16 units. Therefore, the axis of symmetry is the y-axis, which is x equals to 0. And finally, the turning point is actually the same as the y-intercept, 0 minus 16. All right. So this is how you determine the critical feature of a parabola. The next one, y equals x squared minus 10x plus 25, which is x minus 5 all square. In this case, you know that the x-intercept is only 1, 5, 0. There's only one x-intercept or one root. The y-intercept, you can read it from the general form, plus 25. Axis of symmetry is x equals to 5 because this is where the turning point occurs. All right, and again, remember x minus 5 all square is actually y equals to x squared translated to the right by 5 units, and the turning point is the same as the x-intercept in this case. Right. Now, let's have a look at the next one, which is y equals to x squared plus 4. This time, y equals x squared plus 4, you know it's a translation of y equals to x squared up by 4 units. And in this case, there is no x-intercept at all. The y-intercept is 4, 0, not 5, 0. My fault. And then axis of symmetry is x equals to 0. And the turning point is the same, is 4, 0, not 5, 0. All right. So here I've shown you how to plot using your class pad. Also, you can identify the critical features of the parabola. Now, let's look at the graph that I shown you earlier, the general sketch. So, if we have a general form of y equals to x squared plus bx plus c, which can actually be factorized into x plus or minus m, into x plus or minus n, which means you've got two integer, you know that there are two intercepts. All right, so the general form, the root form, actually gives you the two intercept. If it is perfect square, there's actually one intercept. And if you cannot factorize it into one of these form, either the perfect square form or x plus m and x plus n form, there's actually no root or no x-intercept. Just a quick summary. So the x-axis intercept, that is when y equals to 0, is the roots of the quadratic functions. We can observe that there are quadratic functions with two roots, one root and no root at all. Alright, this is generally y equals to ax squared plus bx plus c, or it could be a monic y equals to x squared plus bx plus c. Alright. So y equals to ax squared plus bx plus c can also be written as y equals to a, x plus or minus m times x plus or minus n. The a here is actually the dilation factor. We will talk a little bit more about the dilation factor when we start looking at dilating a parabola. This y equals to a into x plus or minus m, x plus or minus n is known as the root form. Alright, so now I hope you know the difference between the general form and the root form. So here, for a general form of a quadratic equation, y equals to ax squared plus bx plus c, when a is not equal to 0, if we can factorize it, for example, the first one here, we can factorize this as x minus 3, x minus 4. So therefore we know the roots are 3, 0 and 4, 0. In this case, y equals to x squared minus 3x minus 1. You cannot actually factorize it. So what I would like you to think about is, before we go to the next slide, use your class pad to actually plot y equals to x squared minus 3x minus 1. I will not be showing you this graph in the in this lesson. You have to do it yourself. Alright, now in order to solve for the root y equals to ax squared plus bx plus c, that is when y equals to 0, if we cannot factorize it in with two integers, we use the quadratic formula. So we can solve for x when ax squared plus bx plus c equals to 0 using this quadratic formula here. X equals to minus b plus or minus square root of b squared minus 4ac over 2a. Now, before I do anything, before I show you how to actually solve x equals to minus b plus or minus b squared minus 4ac over 2a, I want to pay a little bit more attention to this term here. Square root of b squared minus 4ac. Alright, let's go to the next slide. Here, what I would like you all to do is pause the video for a while and calculate b squared minus 4ac for this. Now, let's go back here again. B is actually the coefficient of x. A is the coefficient of x squared. C is the constant. Alright? So here you know that A is actually 1 because these are all monic. B, constant is 6, and C is slightly different. Alright, so here, if we work it out, these are the answer. Alright, in fact, I should put in square root of 4ac. You can see that with the first one, you actually have an answer, square root of 84. Or you can simplify it as 4 square root of 21. Second one, square root of minus 12. You really can't solve it. And the third one, square root of 0, which is 0. Now, what I've done is I have actually plotted y equals x squared plus 6x minus 12 and the other two for my next slide. Alright, this is the plot that I have. You can see that y equals to x squared plus 6x minus 12, that's actually 2 roots, or 2x intercept. Y equals x squared plus 6x plus 9, 1x intercept, whereas the other one has no x intercept at all. Let's go back one step. Alright. Here, you can see that because x is minus b plus or minus square root of b squared minus 4ac over 2a, if b squared minus 4ac is a positive number, you could have two possible values, plus or minus. Alright, two possible value of b squared minus 4ac. For the next one, if it is a negative number, you cannot actually solve for x at all. B squared minus 4ac does not exist. So here, if you have got square root of 0, the last one, what you can see that b squared minus 4ac is 0, x is actually just minus b over 2a. That's all, because there are no two values of b squared minus 4ac. So in summary, if b squared minus 4ac is less than 0, there's no solutions at all, therefore there's no roots. If it is greater than 0, there are two solutions, therefore there are two roots. If that's 0, there's only one solution, one root. So this term b squared minus 4ac is actually known as the discriminant of the quadratic formula. By calculating b squared minus 4ac, we actually can find out how many roots there are for our parabola. Now, I am actually going to solve these two equations using the quadratic formula. I know that for the very first one, you can factorize it. However, I need to show you how to use the quadratic formula. So in this case, we know for the first one, a is 1, b is minus 7. Don't forget that. The coefficient of x is minus 7, and c is the constant, which is 12. So we know that x is therefore minus b. Actually, I'll write this out first. Plus or minus b squared minus 4ac over 2a. Minus b, I put a bracket in so that I know I've got a negative number. Minus 7 all square, minus 4, a is 1, c is 12, divided by 2 times 1. Therefore, that is 7 plus or minus square root of minus 7 squared is 49, minus 4 times 12 is 48 over 2. Therefore, it's 7 plus or minus square root of 1 over 2, which is 7 plus or minus 1 over 2. So 7 plus 1 divided by 2, that's 8 divided by 2 is 4. And 7 minus 1, which is 6 divided by 2, that's 3. So you still get the same solution. So I would suggest that if you can factorize it into two integer, do the factorization. The next one, we know a is equals to 1, b equals to minus 3, and c equals to minus 1. So therefore, x equals to minus 3, plus or minus square root of minus 3 squared, plus 4 minus 4 times 1, c is minus 1, over 2 times a, which is 1. Therefore, you got 3 plus or minus square root of 3 squared is 9, plus 4 times 1 is 4, over 2 times 1 is 2, which is 3 plus or minus square root of 13 over 2. Alright. If you are not asked to simplify this into a decimal place, you are fine to leave your answer as x equals to 3 plus square root of 13 over 2, or 3 minus square root of 13 over 2. Alright. So here you have learned how to use the quadratic equation to actually solve for x. Alright, we will explore the quadratic formula a little bit more in the next few lessons. Now, what I would like you to do is follow me with one example of sketching y equals x squared minus 9x plus 14. Here you are asked to express the equation into root form and then determine the crucial features of the parabola. We'll start off with y equals to x minus 9x plus 14. Factorizing it, x, which is 7 and 2, minus. So the roots, or x-intercept, is 7, 0, or 2, 0. Alright, axis of symmetry is actually 7 plus 2 over 2, which is 9 over 2, which is 4.5. Alright, so x equals to 4.5, or x equals to 4.5. That's the equation. So now we know that the y-intercept is actually 14, or actually 0, 14, it's coordinate format, and substituting x equals to 4.5. to find the turning point. Y equals to 4.5 minus 7 times 4.5 minus 2, which is 2.5 minus 2.5 and 2.5. So therefore, that is minus 6.25. All right. So that's how you do it. Work out the turning point. Sketch y equals to x squared minus 9x plus 19. So let's do it this way. Y and x. Remember, please use a ruler in the exam or test situation. So we know that one of them is 2, 0. This is 7, 0. And the axis of symmetry, and this point would be 4.5 minus 6.25, and we can just sketch this. Y equals to x squared minus 9x plus 14, and here this point is 0, 14. All right, so I've indicated all the crucial feature. X equals to 4.5 or 4.5. Now, the next one, I would like you to try this. Y equals to x squared minus 4x plus 4. All right, so pause the video for a while and please try this. So we know that y equals to x squared minus 4x plus 4 is actually x minus 2 all square. Therefore, we know that this the root is 2, 0. And we also know that the y-intercept is actually 0, 4. And then we know that the turning point in this case is the same as the root, which is 2, 0. And also the axis of symmetry is actually x equals to 2. Alright, so these two you should remember from the last lesson. Sketching it, y, x. So start off here, 2, 0. So just sketching. Y equals to x squared minus 4x plus 14. The y-intercept is 0, 4, and the axis of symmetry, x equals to 2. Alright, so now you should be able to sketch any graph based on the root form. I would like you to try this question. Y equals to 10 x squared minus 40x minus 210. So you need to be able to express the equation into root form and then determine the crucial features of the parabola. Let's try it. Y is actually 10x squared minus 40x minus 210. Now, you should realize that we can actually factorize this first by taking out the highest common factor. And therefore, this is 10 x minus 7 x plus 3, right? So here, for the roots, 10 x minus 7 x plus 3 equals to 0. We know that 10 does not equal to 0. Therefore, 10 minus x minus 7 x plus 3 equals to 0. X equals to 7 or minus 3. Or the roots are 7, 0 and minus 3, 0. All right. So the next bit, you know that the axis of symmetry is actually x equals to minus 3 plus 7 divided by 2, which is 4 divided by 2, which is 2. So x equals to 2 is the axis of symmetry. Now, for the turning point, so y equals to 10, 2 minus 7, 2 plus 3, which is 10. 2 minus 7 is minus 5. 2 plus 3 is 6. So therefore is minus 300. And then the y-intercept is actually x is 0, 210. All right. So therefore, sketching this, y and x. So we know that it's between minus 3 and 7. And then the axis of symmetry is here. And you can see that because there's no, there's actually no scale. So I can, it's minus 210. My fault, not 210. And we know that this is minus 300, which is 2 minus 300. And then we can sketch this. And then the y-intercept here is 0 minus 210. And this is y equals to 10x squared minus 40x minus 210x. All right. So this is how you actually do it in this case. You can actually factorize it by taking out the highest common factor. Later, you encounter a situation that when you can't do this. The next bit and the final bit of the lesson today is to determine the equation of a parabola. Now, you're asked to determine the equation of a parabola below. You need to express the equation in general form. So here, you're given the roots and the y-intercept. The most obvious thing to start off with, since we know the roots. So we should say y equals to a because we cannot assume that this is harmonic. All right, so we got to work it out using the third point. So y equals to a, x plus 3, because this is minus 3, and x minus 5, this is plus 5. All right, by using this point, by using 0 minus 5, when x equals to 0, y equals to minus 15, we can work out a. So minus 15 equals to a, x is 0 plus 3, x is 0 minus 5. So equals to minus 15 equals to minus 15a. Therefore, a is equals to 1. So the equation is y equals to x plus 3, x minus 5. Let's try the next one using the same idea. Again, I've given you something where you can work out the x-intercept. Actually, let's go back one step. You need to express this in the general form. Therefore, this is x squared plus 3x minus 5x minus 15. So it's therefore x squared minus 2x minus 15. So you must remember it's actually in general form. All right. So let's try this one. So here, if you're going to try this, let's see. Y equals to a. Again, it's x plus 3 because the x-intercept is minus 3, 0, and x minus 5. So this time, when x equals to 0, y equals to minus 30. Let's work this out. Minus 30 equals to a, 0 plus 3, 0 minus 5, which means minus 15a equals to minus 30 Therefore, a equals to 2. So therefore, y is actually 2, x plus 3, x minus 5. In the general form is 2, x squared minus 2x minus 15, which is 2x squared minus 4x minus 30. See, this one is actually the y-intercept. One last example, this time no graphs. You're supposed to determine the equation of a parabola with the x-intercept of 5, 0 passes through the point 0, 50. Here, you can see that this is actually one root only. So therefore, it is a perfect square. So y equals to a x minus 5 square. So when x equals to 0, y equals to 50. So therefore, y equals to a 0 minus 5 square, which is y equals to 25a. A is therefore, oh actually, sorry, this is 50. A is equals to 2. So therefore, this equation is y equals to 2, x minus 5 square. Since I did not specify whether you need to write it in general form, you can leave it in root form. Alright, this is the end of the lesson.